Hey guys, welcome to Teach Me Math. Today we're going to be looking at word problems for linear systems. Now, we're going to be looking at that by just solving a couple of problems. So if you have an idea of how to do it, then try to solve it yourself and then see if you got the right answer. If not, just follow along and I'll explain how I'm doing it step by step. I haven't done any of the problems before, so I'm going to be doing it step by step because I'm trying to solve it. Alright. So before we start, there's just one thing I'd like you to keep in mind. When we solve linear systems, when we solve word problems, I like to keep this rhyme in my head. Two equations, two unknowns. Alright, so it just helps me keep my eye on the prize kind of thing. So this is unknowns. Okay, that looks a little bit weird. I'll write that back again. Okay, two equations, two unknowns. Alright, so let's see what that means in the first problem, which is going to be a little bit of the easy one. So, the sum of two integers is 63. The smaller is 11 more than 1/3 the larger. Find the integers. Alright, so I have two separate lines giving me two separate pieces of information. The sum of two integers is 63. There is a smaller integer and there is a larger integer. So, those are my two unknowns. Now, from these two unknowns, I'm going to create two different equations to find my two unknowns. My first unknown is my smaller. So I'm going to label this S, standing for smaller integer. And I'm going to label this one L, okay, for my larger integer. Now, the sum of two integers is 63. There it is, equation number one. The sum of two integers, which is my S integer, my small integer, plus my L integer, is equal to 63. Alright? That's equation number one. And the second line is going to give me equation number two. The smaller is 11 more than 1/3 of the larger. So S is 11 more, so is 11 more than 1/3 of the larger, than 1/3 of the larger. Does that make sense? So S is equal to 11 plus 1/3 L. That's going to be my two equations. Now, how do I solve these equations? I'm going to solve the way that we talked about before. I have two options. I have my substitution and my elimination. I stated in the previous problem that substitution is my go-to, so that's the only one I'm going to be using, but rest assured that anything I solve using substitution, I can also solve using elimination. But in this case, it's kind of obvious that substitution is the correct way to go because I've already isolated one of my variables. S is equal to 11 plus 1/3 L. And if S is equal to this phrase, then I can just plug in S into equation number one. So, my first step is to plug equation 2 into equation 1. Awesome. So let's do that. So 11 plus 1/3L is equal to 63. Alright, now let's open up the brackets. So 1/3 plus 3/3, that's going to be 4/3. So 11 plus 4/3L is equal to 63. Then isolate L. 4/3L is equal to 63 minus 11, which is going to be 52. And L is equal to 4L is equal to 3 times 52, which is going to be 156. And L is equal to 156/4. That's going to be a 3, and that's a 36, and that's going to be a 9. Right? So L is equal to a 39. Therefore, S, right? So now we can find S because we can plug L into either equation and we'll get S. So let's do it into equation 1. So in 1, S plus 39 is equal to 63. Therefore, S is equal to 63 minus 39, and S is equal to 23, no, 24. Alright? So 24 plus 39 is going to give us 63. There you go. That's problem number 1 solved. Alright? So, first step, the hardest part, is figuring out what my 2 equations are going to be from the given. So if I break it down into finding my 2 unknowns, then I can use that to find my 2 equations. 2 equations, 2 unknowns. Alright, so we're going to go into problem number 2. If you want, you can pause it here and then try to solve it yourself. If it doesn't work out, then unpause and you can follow along to see how I did. Alright, a 100 kilogram mixture of peanuts contains peanuts of 2 varieties. Well, 2, that means those are my 2 unknowns. One is priced at $2 per kilogram and the other is priced at $2.40 per kilogram. If the mixture is priced at $2.08 per kilogram, how many kilograms of each kind of peanut does it contain? Alright, we've got our 2 equations and our 2 unknowns. My first unknown is going to be the one priced at $2 per kilogram. Okay, this is going to be my x. Okay, we don't have any letters specific for this one, so I'm just going to do x and y. And the other is priced at $2.40 per kilogram. That's going to be my y. Okay. Now, this is going to be y kilograms of peanuts, and this is going to be x kilograms of peanuts, because I'm looking for how many kilograms of each kind of peanut it contains. So, 100, so now that we know what our 2 unknowns are going to be, let's figure out what our 2 equations are. A 100 kilogram mixture of peanuts contains peanuts of 2 varieties. Well, there you go. Equation number 1, x kilograms plus y kilograms is equal to a 100 kilogram mixture of peanuts. There's equation number 1. One is priced at $2 per kilogram, the other is priced at $2.40. If the mixture is priced at $2.08 per kilogram, how many kilograms of each kind of peanut does it contain? Alright, so there's a 100 kilogram mixture priced at $2.08 per kilogram. Well, then the total price of the mixture is going to be $208, right? So if I'm looking back at the 100 kilograms, $2.08 per kilogram, it's $208 for the entire mixture. Now this total price, if you take the $2 per kilogram multiplied by the total number of kilograms plus the $2.40 per kilogram multiplied by the total number of kilograms of that variety, then you're going to end up with a total of $208. Alright, because x plus y is equal to 100, and if you multiply each one by the amount that it's worth per kilogram, then you should get $208, and that will be equation number 2. Alright, now let's solve. Let's solve by substitution. So it's harder, so this is going to be a little bit difficult to isolate a variable from here because you're going to have to do a little bit of division. So let's isolate it from here. Let's isolate x. So we just say x is equal to 100 minus y. Okay, and this is going to be my equation number 3. Then our next step will be plug equation 3 into equation 2. Okay, no problem. So we will substitute our x. 2 into 100 minus y plus 2.40y is equal to 208. Okay, so 200 minus 2y plus 2.4y is equal to 208. Let's take the 200 to the other side. Negative 2y plus 2.4y is equal to 8. Then let's add these two together. We're going to end up with 0.4y is equal to 8. Okay, then so 0.4 is a 4 over 10, so 4 over 10y is equal to 8, and then 4y is equal to 80, and then y is equal to 20. Alright? Sorry, that looks a little bit messy, but I was progressing this way. just to show the progression of my thoughts. So y is equal to 20. Are we done? No, because now we know there's 20 kilograms of the y variety, and to find the x variety, then I just plug this back into equation number 1, that's over here, then x plus 20 is equal to 100, therefore x is equal to 100 minus 20, which is 80 kilograms, okay, and this is 20 kilograms, and then those are my two. If you got 80 and 20, then you are absolutely correct. 80 kilograms of the $2 per kilogram variety, and 20 kilograms of the $2.4 per gram variety. If you have any more questions or you didn't understand what I did, if you would like some more problems, I can definitely find some, or anything you'd like me to go through, please send me a message and I'll be glad to help out. Thank you.